think we've now come to the point where we can educate you on how to actually do the querying, and we'll run some queries and get some results in the Atlas web portal. So this is what we're going to look at. So you don't need to memorize this or really look closely at it, but we're going to go back to that bookstore scenario. And we have customers and we have books like we've been talking about. And as we mentioned, we'll keep the ID of each book and the title so that we can relate those back and forth. So in our example here, we'll just have 2 customers and we'll have 2 books. So that'll set that up. So then we can next dive into actually how to query these. So just to give you a brief introduction first about what we're going to do is that there's the concept of these criteria. There's the query criteria and the projection criteria. If we go back to our example, I've simplified the documents. So we have 2 people here, 2 customer documents, and we want to do a query for anybody in our customer base that's over 35. Maybe we think that that's the age cutoff of interest in a certain book that we want to market to people. So we want to first give the query criteria. What that'll do, it will filter down to a document in our case. If, of course, there were thousands of people in our database that were over 35, then it would give us a whole bunch of documents. But in our case, we only have one that's returned. Now, the projection criteria then is different. That says, from the original document, what do I actually want to get? And in our case, the only thing we want to get is the name and age. So you can see the flow here, right? So here's the 2 documents. We do the query criteria, and we get the single document with all of its properties. And then we do the projection, and then it gets it down to name and age. Now, ID always comes. I mean, you can get rid of it. If you don't state whether you want it or not, you're going to get it in the final document anyway on your output. Here's the Atlas portal that I've opened up. And I've gone to select my Newswatcher database, my Newswatcher collection, and then I can insert documents into that. So I can go insert document. I could type it in, or copy and paste. It only lets you put in one document at a time, so that wouldn't work. So I could put this one in. Now I've already put them in, so they're in there already. I just wanted to show you the UI for putting those in. So the next thing we want to do is look at querying. So here is this UI to enter your query criteria. And if you click on options, it lets you also enter your projection criteria and do a sort or a collation. So let's try out some of our queries. For our first query, let's do something that's rather simple. We're just going to search for a single customer, and we know that they have IDs, right? They're put in there either assigned by MongoDB when something's inserted, or we can assign it. So we assign the IDs, and I gave one of the customers an ID of 77 and the other 78. So here's the syntax for the filter. You basically give it the field, which is the property. Field is what Mongo calls it in their documentation. So we want, for the ID, you put that on the left. And then on the right side, there's some syntax then to specify what to do with that field. In this case, there are these ability to filter or query by these $equal, which there's also $less than, $greater than. So we're going to use the $equal. Now for the projection, this is where we don't want the whole document returned. If this wasn't in here, then we get the whole document. Otherwise, we run the query, and you can see we got just the one document, and we've got Joe Schmo, who's from Kansas. As an alternative, just for the equal, you can simplify that and just say, ID 77, and it does the same thing without the $equal. Also, like JSON, you can put in the double quotes. Numbers don't need to have strings around them. The fields don't have to have double quotes if they're just the top level simple ones. If they have, like this one, it's more complicated in the hierarchy, then it requires to have the double quotes around it. Now let's also just show if there's no projection criteria, we get the whole document. Here's a list of the query criteria operations you can use. So we used the equal one so far on comparison. Like I said, there's different ones you can do: less than, equal to, not equal to. There's also ones you can use across arrays. We'll show examples of those. Bitwise, and then other different types of operations, plus the logical ands and ors that you can put in there. So here's an example then where you can have multiple of these comparisons. If you look then at the books document, the book type documents, we have pages, number of pages. So this will search across all the books, and it will fetch any of the books that have pages that are greater than 100 or less than 100. So here's the result of that. There's only one book returned for that query. You saw the $and in there, so what if we wanted to look across more than one field and do some criteria across that? So here we have one where we use the $and. Then inside brackets, square brackets, we can have an array of the tests that we want to do. So back to the pages one that we did, we'll look for any books that have pages less than 200 and are also in the category that equals software engineering. And there's one book returned for that. In the case of the $and, there is an implicit way to do that and get the anding just with this syntax. So you just give it comma separated. So it's pages less than 200 again and equal to software category engineering. Returns the same thing. However, you do need the $and if it gets a little bit more complicated than that. So here's one that's more complicated. This is using an and then there's also an or. So if we state the English for this, then it would be pages less than 200, and it has a category of this or this. So if we altered this so it wouldn't find anything, this or condition is not going to return, and we don't get any documents because it has to be pages less than, and there has to be something that satisfies this down here. There's an alternate syntax that you can use for this $or. Instead of having this array and listing each of those out, we can replace this with an in syntax. Category in software engineering or science fiction. Let's take a look at what we can do if we have documents that are free form. We may have documents that are still of type book type, but are missing things, like they don't have book reviews or they don't have a publication date. So here we're looking for any books. We're not actually looking for book type. This will find any documents out there. We'd probably want to say type book type if that's really what we're looking for. But anyway, if we want books of less than $30 and have a publication date, so there's this $exists that we can use as a test to make sure it has that property. Otherwise, we won't get the books. And it returns both because they both have a publication date in this case. Here's something that might trip you up. Here's a test. You saw this before. We looked for user documents, IDs equal to 77, and we got something. However, this time we don't. That's because MongoDB doesn't do like JavaScript does. So if you're a JavaScript developer, you know you can say 77 equals 77 in double quotes, and that will work, but that does not work here. So it has to be exactly matching the type in order to work. We talked about the projection criteria, but I didn't quite cover it in full detail, so let's do that now. You list each of the fields that you want to be shown. So here's name and books purchased, and you know that books purchased is actually an object that contains sub-objects. So the syntax is to have a 1 if you want it shown and a 0 if you don't want it shown. Now, this won't work. We put name at 0. It's an error. You can't mix and match. So you can either state what you want to show or you can state what you don't want to show. Okay, so we left out name and we left out books purchased. The only exception to that is if you don't want the ID. So we can say underscore ID, and this time we can say 0. All the queries we've done so far have been basically fetching data and doing a get. And there's also the ability to do updates. So here's some of the update operators. Let's look at array update operators first. You can update, if you have an array inside your document, you can pop something off of it, you can push something on it, and those are some of the more complicated ones to think about, and we won't show examples of those. The regular updates that you'll see most of the time then are for a set. So a dollar set, this is where you want to put something in a currently available field and you want to change it, you want to update it. Unset would actually remove if you want to remove a field, or you could rename a field. You can take an existing field that has a number and you can increment it, or you can multiply it by something. Or you can replace it if the thing you want to replace is greater or less than the current value. Unfortunately, you can't use the Atlas portal like we were doing to query to actually do an update. So I'm just going to have to show you some code and how you would do that in the code. Now, we illustrated how to do these types of things in the Node video, so you can go back to refer to that. We simply call the update. This is the query criteria. So we're looking for that first customer. Now each customer has reward points. And here's a case where we don't care what the reward points were before. We're just going to set it at 1,000. So this would set the reward points to 1,000. However, this one, if this was run, it would take whatever the existing value is and it would add 10 to it. So if this first one was done, it would be 1,000. Then we'd increment it, and then it would be 1,010. And then this one does this $max. This means whatever the max is, right, it will set that to it. So if it already has a value that's higher, then it will keep it. In this case, let's say we have 1,010 in there after this operation. This one would then be able to set it to 2,000. The topic of indexes is very important. Without indexes, your performance will likely be very slow, especially if you've got lots of documents that you're trying to search across. We're trying to illustrate here then, each row would be a document. This is the typical way you would show a relational database table. However, we're just going to use it for our purposes here to illustrate the same type of concepts that are available in a document-based database. So here's a case where you may have all these separate documents, last names, Smith, Williams, Adams, and Tuttle, and the rest of the data that exists in the document. Now, if you wanted to search for, say, Adams, you could do that in a query, right? You could do the query criteria where you're looking for Adams. Unfortunately, you're not guaranteed how long it's going to take to return Adams. It could be pretty slow if you got a lot of documents. It's going to basically sequentially look through all the documents until it finds Adams. To solve that problem, indexes were invented, and indexes exist in DocumentDB as they do in other database types. And what we've got then is an index. So you can tell MongoDB to create an index on any of the fields that you want. There's certain restrictions about that, and you can understand those. However, for our simple case here, we'll just cover what if I want to index on the last name field. You can do that, and then an index is kept, and you can find things easily. So now it's basically ordered alphabetically, and you can actually order it in reverse alphabetical order as well. So here we've created an index in alphabetical order. Now if we're searching for Adams or Smith or Tuttle, the database can be more effective, like with a binary search or whatever it uses, to really come to a quicker conclusion as to if it can find that document. Then from there, it has a link that it can go directly to find that document. Here's some examples of what you would do in the portal. So you can create indexes either in code, from the command line, or in the portal. I've created mine for Newswatcher in the portal. These ones have to do with our sample bookstore application. Here's some examples of what you would want to do. So let's say you wanted to look up continuously to find, let's say you wanted to target some marketing just in one zip code. So to do that, you would create an address .postal code index, and you would say 1. Here's one down here that does age, and you're doing -1, and all that does is it does it in reverse order. And the only reason that's important is when you get your documents then back, if you want them sorted in a particular order, then you will get them in that order. So in your code, that's the way they'll show up, or in the portal, that's the way they'll show up in that ordering. Here's an example of creating an index that uses 2 different fields. So you may have query, so this depends on the query criteria. Perhaps you find yourself doing queries often by age and reward points. You want to find people under 20 that have no rewards points. So you can create an index for that. Now, just realize that you then can't just query and look for reward points. It has to be both age first and then reward points. It can be just age, but it can't just be reward points and use that. You could create 2 separate indexes then if you really wanted to sometimes do age, sometimes do reward points, sometimes do age and reward points. We talked about doing a minus. Now, there are also some things you can do when you create an index to make sure that there's only one document that has a field with that value. So email is a great example. You have customers in your database, and you want to have unique customers. So each customer has a unique email address, and you can't create another document that has the same email address that existed in another document. So whichever one was created first will get to stay there, and a second one that tried to get created and had that field email with the same value, it would fail. So you just say unique and you say true. Now there's also something you can do called sparse, and that is something that you would set up if you want to uniquely find documents and only the documents that contain that field. Email is a bad example, but you may have some other property in there that you're experimenting with and not everybody has it. So let's say, the rewards was something you're experimenting with. So when you do queries now and you've indexed on rewards and you're doing a query criteria with rewards in there, it will only consider documents that have that. Then you need to be careful because you may say, oh, why didn't I get, I was searching for people in this zip code with rewards, and you forget about it, but you don't get all the documents you expected because it's this sparse usage. You may be interested to know actually how it's being hosted on machines underneath. It's kind of an interesting topic, and it is important because of several things that we're going to talk about operation-wise for your MongoDB instance. Whenever you set up a MongoDB cluster, which is the term used by Mongo, the cluster has several machines, and these are machines then that contain your documents and your collections and your databases. There's always a primary machine. All writes have to go to that, and then reads could go to that. You can then also have these secondaries. Well, they're always set up for you in this cluster. That's for the replication usage. And the reason this is important is because if that primary machine fails, you can then fail over to one of the secondaries. And then there's an arbiter that really helps pick the secondary. If the primary comes back, then it switches back to the primary. And then you can read from the primary, or in the code you can say, I don't really care if it's up to date. You can set a flag to basically say, or one of the options can be stated that I want to read for a secondary, but I don't care if it's up to date. let's say we're talking about last names in our collection, in our documents. And those, can have letters, right, that starts with A to Z. And those are all in the same collection. Now our company is growing larger, but at some point you're just going to simply run out of storage on the SSD or the storage device for that machine. This is where Mongo has these processes that are governing your access. And there's actually a Mongo process that is giving you access. There's another process then that's on top of that that gives you this access in general. So if you look at the diagram here, each of these shards, we call it a shard, is actually one of these clusters. And so Mongo is organizing your data and splitting it across these clusters, and we call them shards. So we have 3 shards, A, B, and C. Now, I've arbitrarily decided that, A through I is going to go here, J through Q, R through Z. Mongo is actually going to decide for you based on what's called a sharding key. So just like we had an index, we have a sharding key, and it looks exactly the same as our indexes. So we could say name, and that would be, :1, and that would be our sharding index. Now when you insert documents, Mongo decides where they go, and they basically go in blocks. And so blocks of data then is written to these different shards and then kind of kept and balanced. So there's a lot of intricacies here that go on. You'll never see a shard get overloaded because Mongo's continuously balancing to make sure it's kind of fair across it. Because when you come in and want to find something, then it has to know, where it's going to find that. Now, obviously, you can try and find something not by last name, for example, and then it's basically going to just go to each shard. So let's say you were doing a query criteria by age, then it can't use, that name. You could set up the sharding key to basically contain name and age. So it's you have to be careful about how you set up the sharding key because there can only be one sharding key. We started off earlier on talking about modeling your database. So this is looking at what I did for the Newswatcher application. Here's some of the documents. We have the major stories document, shared stories, and user documents. And you can query for those with a query criteria like this. There's also the ability to do some monitoring. And this is a snapshot of some screens that I took from monitoring that you can do. And so for this, I can basically go in and view the monitoring and whatnot and see what's going on. So just be aware if you're on the free tier, there are some limitations. One of the other things that's limited is the IOPS. So there's only so many IOPS that you can have, like 100. If you go to the other database versions that you can use, you can, if I go to the upgrade, we probably can see that there are different ones that you can use, and this changes from time to time, right? So there's an M10, M20, and you can see that you can scale up how much storage, and you can scale up the IOPS. So if you want 1,000 IOPS, or if you really want to go up to the most expensive one, then you can increase that ability there. So that covers it. That's our data layer with MongoDB, and it's part of a 3-part series. The data layer, we only had one video, so this is the only video on that. However, if you want to go back to really see the full stack JavaScript development, overall, then you'll want to go and look at the React videos, the 3 videos there, 2 for introduction and then 1 on Newswatcher. And then the Node for the middle service tier, Node and Express, and we cover that JavaScript, and we give you 2 introduction videos, and then the Newswatcher explain how that works. So I encourage you to go back to look at that. And of course, get the book that I wrote. Here's a picture going to be shown here in a second of what that title is and what that looks like. But that gives you a lot. I couldn't put all the information that's in my book into my video. So if you go to if you read the book, then you'll see a lot more detail. I'll walk you through how to set up Atlas, how to get your database going, So I think it's good to have a video, kind of let me talk through it, as well as, turn to the book for an added resource to kind of supplement and work back and forth to get the complete understanding, to get you up and running doing full stack JavaScript development.